Okay guys, welcome to section 3.5. This section is all about symbolic arguments. A part of why we are learning about all the truth tables is so that we can see whether arguments are valid or not. And so what we're going to do is break arguments down to symbolic logic, and then we're going to prove whether they're making a valid conclusion or not. A symbolic argument is going to consist of premises and a conclusion. Okay, so typically you'll have a premise like, if you are on Facebook, then you are my friend. That would be a premise. And then usually there'll be some type of conclusion like, if you are my friend, then you like rock music or something to that effect. Our goal is to prove whether an argument is valid or invalid. If an argument is valid, then it'll follow from a necessary set of premises, and you'll end up with like a tautology when you do a truth table. If your argument is invalid, then you'll have a fallacy or something that's not true, and you'll know because you won't get a tautology. One of the most common ones that you're going to work with is called the law of detachment. Okay, and so the law of detachment is also called modus ponens. Symbolically, it's written like this. If P, then Q is premise 1. Premise 2 is that P happened. So the conclusion is therefore or then Q. So, for example, if you are my Facebook friend, then you like ice cream. You are my Facebook friend, therefore you like ice cream. If you ever see this law of detachment, that's an example of a valid argument. In order to prove that it is valid, what you'll have to do is you'll have to take the first statement, if P then Q, and do an and with the second statement, P, and then you'll do a conditional, therefore Q. And you'll have to show that in the therefore column you have all true statements. So I can show you what like. When you do this, the first thing you have to do is translate the paragraph that you read. Okay, so if they give you a paragraph, you need to translate that into symbols. Then you can either compare it to a bunch of arguments that you know are already valid or invalid, or if you don't remember which argument is valid and invalid, you can do a truth table. And when you construct the truth table, you take the premises and you put an and between them. And then you do a conditional with the conclusion. And after you construct your truth table, if you get a column of all truths, then you know that the statement is a tautology and it's a valid argument. If you don't get all truths, it's invalid. Okay, so for example, let's look at this first one that I have here for you. Determine whether the following argument is valid or invalid. If you watch Good Morning America, then you see Robin Roberts. You did not see Robin Roberts. Therefore, you did not watch Good Morning America. Okay, so let's prove whether this is a true statement or not. Okay, so first thing we're going to do is we're going to make a symbolic translation of what we have here. Okay, so I'm just going to stick this up here in the corner so we can look at it in a little bit if we want to. Okay, so the first statement says, if you watch Good Morning America, then you see Robin Roberts. Okay, so I'm going to translate that. That's a conditional, if P, then Q, where P would be you watch Good Morning America, Q would be you see Robin Roberts. Okay, so our first premise is if you watch Good Morning America, then you see Robin Roberts. So if P, then Q. Okay. Our second premise says you did not see Robin Roberts. Well, seeing Robin Roberts is Q. So not seeing her is the negation of Q. And now I get to write the conclusion. The conclusion is then you did not watch Good Morning America. Well, watching Good Morning America is P, and supposedly we did not watch it, so that would be the negation of P, and that's our conclusion. Okay, so we want to prove that this is true. So to prove this is true, we're going to have to first find P and Q. We're going to have to find if P, then Q. We're going to have to find the negation of Q. And then we're going to have to find the statement, if P, then Q, and not Q. And once you get that column, you are going to do a conditional with that column, and then you're going to do the conditional with not P. And this will be, the conditional column is going to be the one that you're looking for to see if it's a tautology or not, and see if it's all true. Okay, so let's try this. So if we have two statements, statement P, true, true, false, false. Statement Q, true, false, true, false. Now you'll have to find the conditional, if P, then Q. So remember, the only time if then is false is if you get a true, false. Every other time it's true. Then you'll have to find your negation of Q, false, true, false, true. And then you'll have to take the if P then Q and the negation of Q and calculate the and. So remember, the only time the and is true is if you get a true, true. So we've got a true, false, a false, true, a true, false, and a true, true. Okay, so we have 3 falses and 1 true. Now, we then need to calculate the negation of P. So remember, P was true, true, false, false. So the negation of P is false, false, true, true. So you need to take the and column and the negation of P column, and you need to do the biconditional there. So false, false is true. False, false is true. False, true is true. And true, true is true. So you got a column of all T's. That is a tautology. That means that this is a valid argument. So according to this argument, if you watch Good Morning America, you're going to see Robin Roberts. And since you did not see Robin Roberts today, then you probably did not watch Good Morning America. Valid argument. Now, some people do not like to go through and make a truth table every single time because they think it takes too long. So there are 4 common forms when you do a verbal translation that you can tell whether the argument's going to be valid or not. The first one is the law of detachment. So if P, then Q, P happened, therefore Q had to happen. If you ever translate and it turns out to look like that, it will always be a valid argument. The second valid form you're going to run into is the law of contraposition. If P, then Q, Q did not happen, therefore P did not happen. If it translates in that form, it's always valid. You don't have to do a truth table. You can mark valid. The law of syllogism. If P, then Q, if Q, then R, therefore if P, then R. So if you see that, that's always valid. Disjunctive syllogism. P or Q, P didn't happen, therefore Q must have happened. So again, these are just shortcuts. If you cannot remember them, you can do a truth table every single time and prove whether the argument is valid or invalid, although these shorten the process considerably. There's also forms that these 2 forms are always commonly invalid forms. The first is the fallacy of the converse. If P, then Q, Q happened, therefore P happened. That is false. That's an invalid argument. And then the last is the fallacy of the inverse. If P, then Q, P didn't happen, therefore Q didn't happen. That's also not true. So like if you were talking about that Good Morning America example, if you watched Good Morning America, then you saw Robin Robbins. You did not watch Good Morning America, therefore Robin Roberts wasn't on it. Well, that's not true. So if you ever notice these forms, don't bother making a truth table. You can just use the rules and be done. Okay, so let's look at one of these situations, okay? So it says, determine whether this is valid or invalid. So if you are on Facebook, then you see my pictures. Okay, so let's write that as if P, then Q. If you see my pictures, then you know I have a dog. Well, seeing pictures was Q. So if Q, then you've seen my dog, then R. If you are on Facebook, then you know I have a dog. So being on Facebook was P. Knowing I have a dog was R. And so you've translated it. If P, then Q. If Q, then R. Therefore, if P, then R. So you would not have to make a truth table on this because this is one of the valid formats. This is the law of syllogism. So you could just stop right there with your translation and you could say this is valid. This is the law of syllogism and I'm done. If you want to do a truth table, you absolutely can. It would be very lengthy. You would first have to calculate P, Q, and R. You would then have to calculate if P then Q. You would then have to calculate if Q then R. You would then have to calculate the and between those. You would take that column and do the conditional with that column and the if P then R column. So you would have to do 1, 2, 3, 4, 5 columns in order to figure out whether it was a true statement or not. So it could be very lengthy. All right, so let's look at another example. Okay, just tell me whether it's a valid or an invalid argument and why. Okay, if it is snowing, then we put salt on the driveway. Okay, so let's say it's snowing is P and salt on the driveway is Q. So it said if P, then Q. There's premise 1. Premise 2, we put salt on the driveway. So Q happened. Therefore, it's snowing. Therefore, P. Okay, so we have the argument. If P, then Q, Q happened. Therefore, we feel P happened. This is going to be invalid. If you look at the argument, this is the fallacy of the converse. Okay, so what this says is if it's snowing, we put on salt. We put on salt, therefore it had to be snowing. Could somebody have put salt down even though it didn't snow? Sure. So this is an invalid argument. Again, you can do a truth table if you want to, or you could just recognize that it's the fallacy of the converse and just be done and call it invalid. Let's try one more similar argument. If it is snowing, then we put salt on the driveway. So again, we could say if P, then Q. It's not snowing, not P. Therefore, we do not put salt on the driveway. Therefore, not Q. Okay, is this valid or is this invalid? Okay, again, this one is the fallacy of the inverse. So if you look at your little table that I put on the previous slide, this is an invalid argument. And so you would not have to do a truth table. You would not have to try to find the column of all t's. This fits the fallacy of the inverse. So invalid argument. Okay, last but not least, sometimes they'll give you 3 premises and 1 conclusion. In those ones, you're not going to have a choice. You're going to have to make a table and do the and between each premise and then do the conditional and see if it's true or not. Okay, so let's see. If my cell phone company is Verizon, then I can call you free of charge. I can call you free of charge, or I can send you a text. I can send you a text, or my cell phone company is Verizon. Therefore, my cell phone company is Verizon. Let's figure out if this is a true statement or not. Okay, so I'm going to scooch this out of the way because we're going to need some room. And the first thing we're going to have to do is translate this into the 3 premises and the conclusion. Okay, so premise 1 says, if my cell phone company is Verizon, so then I can call you free of charge. So if P, then Q. That's premise 1. Premise 2, I can call you free of charge, or I can send you a text message. Okay, well, calling you free of charge is Q, or is your little V symbol, and then sending a text message will have BR. There's premise 2. Premise 3, I can send you a text message, that's R, or my cell phone company is Verizon, that's P. Therefore, here's my conclusion, my cell phone company is Verizon, so that's P. Okay, so here's what we're going to have to do. We're going to have to do if P then Q,